everyone, let's have a look at momentum. What is momentum? And we know that has to do with movement, with an object that has movement. Now, if we look at the definition, and we're going to use the small p for the symbol of momentum, we're going to say, okay, what is momentum equal to? If I take a bullet, which has a small mass, but a high velocity, it's got a lot of momentum to destroy something. If I take that same bullet and I just drop it, no, not the same momentum at all. So, if we look at momentum, not only is the velocity important, but also the mass. For instance, if you look at, let's say a group of, I don't know how many of you watch rugby, but if you have a rugby team and there's only one guy moving with a rugby ball towards the goal line, what happens is if the whole pack comes behind him and they add their mass to that one person and they all go, even though slower, but they add mass, the whole momentum increase. So if we look at the definition for momentum, and that's actually an easy one to remember, because you just have to look at the formula. So the formula states that momentum equals the product of the mass times the velocity. And we don't use the word speed, we use velocity, because it's a vector. It's important that you also always mention in what direction is your momentum going. Alright, so if you look at what would be the unit, the standard unit for momentum, we're going to measure mass in kilograms, and we're going to measure velocity with meters per second. And that's it. We're not going to use a different unit at all. So it's just going to be kilogram meters per second for momentum. So that's easy enough. Now, if we start to look at changing of momentum, it gets interesting. For instance, if you watch tennis, and let's say it's Nadal, and he is serving. He's serving at, let's say, 200 kilometers per hour. Now, I'm facing him with my tennis racket. I need to change the momentum of that ball into the opposite direction. So, the change in momentum is quite important. So, if we look at change in momentum, we're going to use the formula of P, change in momentum, equals your final momentum minus your initial momentum. And that is how you're going to determine what is the change in momentum. Let's say of that tennis ball getting served to you, it's moving towards you. Now it's going to be hit back. So I'm changing the momentum of that tennis ball, goes opposite direction, and now I have to work it out, and I'm going to say, okay, what is the mass of the tennis ball? And I'm going to say, what is the final velocity minus the original velocity? And it's very important, I cannot emphasize it enough, guys, that you have to choose a direction. Now let's look at a very a simple example. Let's say you throw a ball against the wall. Okay, so let's say I throw that tennis ball against the wall. Let's make the mass of the tennis ball 1 kilo, because we don't want to do too much work with working out. A difficult sum. And let's say it's moved with a velocity of 2 meters per second towards your wall. When that ball bounces back and moves in the opposite direction, and you notice that I use the arrows because it's a vector, it's going to, let's say it comes back from the wall with a velocity of 1 meter per second. Now you need to work out what is the change in momentum. So what you're going to do is you're going to say, okay, the change in momentum is the final momentum minus the initial momentum. So, okay, so let's choose that direction as my positive direction, which gives me then my final momentum as -1. Okay, so let me just show you the formula again. So it's going to be final momentum minus initial momentum. Final momentum, 1 times 1, it's -1. Minus original momentum, 1 times 2, so -2. So you see that I get a -3 kilogram meters per second, and I have quite a large number for it. So 2 towards there, 1 coming back, and that equals a change in momentum of -3 kilograms per second. Now, an important thing, guys, if you want to show this as a vector diagram, you have to now focus, because it's not the vector diagrams that we used in grade 11 to get a resultant. This is not a resultant we're looking for. We're looking for the change in momentum as a vector. So what you're going to do then is you're going to say, all right, let's say this is my first momentum. So that is P initial. What you then do is start from the same point again, and you're going to say, okay, what is the second or the final momentum? So the first one, P initial, was equals 2. So let's say it's 1, 2, and it's in a positive direction, plus 2. So if we're now going to say, what is the final momentum? And that is the important part to remember. Start at the beginning again. So don't use where you just add it there, like we did in grade 11. No? That is not the resultant that we're looking for. So you're going to add the first one, which was -1, in the opposite direction. So you see there's my opposite direction, and it's my final momentum equals -1. So how do I now show the change in momentum? You're going to do it like this. You say, okay, the end, start from the end of the first momentum, initial momentum, all the way to the end of the final momentum. And just to make sure that you did draw it right, just check yourself. So it's going to be 1, 2, 3, a value of 3. And in what direction? If I chose that direction as my positive, it's in the opposite direction, and that equals then your change in momentum. So you see, just focus when you do this as a vector diagram, and they ask you for the change in momentum. Let's have a look quickly at another example. Let's say it's the same thing. I'm again throwing the tennis ball. Again, let's say P initial equals 2 in that direction. But instead of now hitting a wall and bouncing back, it goes, let's say, through tissue paper. And it continues in the same direction, but now with a final velocity of +1 in the same direction, velocity +1. So now we're going to say, okay, so the final velocity would then 1 kilogram times 1 meters per second. So it's a +1 kilogram meters per second, but in the same direction. Now, can you show this as a vector diagram? Show the change in momentum as a vector diagram. Now what we do is we're going to say, let's first work it out, just to make sure that we check ourselves, okay? So it's going to be change in momentum, yes. So it's P final, yes. Minus P initial. Final momentum was 1. Original momentum was 2, or initial. So what does it give me? -1 kilogram meters per second. Alright, now let's draw that as a vector diagram. Okay, so here we go. Let's say I start here. I'm going to draw the 2 kilograms meters per second in as my P initial. Then I'm going to start again at the same point, and I'm going to draw in the second one, which is a +1. So that is my direction that I selected as my positive direction. That was my P initial. That's my P final. So what is the change in momentum? Let's have a look. It's going to be from the end of the first one straight towards the end of the second one. And am I correct? Yes, we work it out as a negative direction, so my arrow goes in the negative direction. And what is the final answer? It's a -1, so it is 1 and minus in the opposite direction. So that would be my delta P. So that is momentum, and that is change of momentum. So whenever you have something that either the velocity, well it's going to be a change in velocity because you're not going to change your mass while you're moving. But as you move and your momentum changes, either in the opposite direction or continue in the same direction, how am I going to work that? The difference out, my change in momentum, I'm going to say P final minus P initial. Alright, so that is the easy one. Hope you got it. Let's see you again. Believe in yourself. You can do this.